Before I start my projectile motion project, I'd like to give you a brief definition of what projectile motion is. Projectile motion is a branch of classical mechanics in which the motion of an object, the projectile, is analyzed under the influence of the constant acceleration of gravity, after it has been propelled with some initial velocity. Right there. The problem that I chose to do was number 1. A golf player strikes a ball on the ground, giving it an initial velocity of 50 meters per second at an angle of 34 degrees above the horizontal. The first question is, what is the maximum height the ball achieves? The second question is, how far does the ball travel? So first, I drew a picture to show that the golf player was striking the ball on the ground, giving it an initial velocity of 50 meters per second at an angle of 34 degrees above the horizontal. So because we were only given the angle, I figured I had to find the initial velocity of x and the initial velocity of y by doing the Pythagorean theorem, which is what I did there. And first I figured out that 50 cosine of 34 was the initial velocity of x, so I then did that on my calculator and got the initial velocity of x was 41.45 meters per second. And then to find VIY, I did 50 sine of 34 and got VIY to equal 26.96 meters per second. So after I decided to put everything into a chart, and because in the graph we know that VI and VF are the same for x, I put in 41.45 for x after finding it over here, and 41.45 for VF because they're the same. And then because I knew that VIY was 27.96, I put that in there. And in these type of problems, it's given that the acceleration for x is always 0 meters per second, and for y it's always negative 9.8 meters per second squared. So once I had enough information for y, because I had VI of y, which is 27.96, then I have VF of y, which is 0 meters per second, and the acceleration for y was negative 9.8 meters per second squared, I plugged it in for this equation, VF squared equals VI squared plus 2a delta d, and so I plugged in 0 for VF squared, 27.96 squared for VI squared, plus 2 times negative 9.8 times delta d, and for 27.96 squared I got 781.76, but because you have to put on the other side it's negative, and for this I got acceleration delta d, it's negative 19.6 delta d, and because the negatives cancel you get 39.89 meters. So what 39.89 meters represents is delta d for the y value, so that's right here. So right there we can write 39.89 meters. Okay, so we figured that out. And now what we have to do, so that's the maximum height of which the ball achieves. Okay, so for the second question, it says, how far does the ball travel? So for this one, we have to make a different chart. So I have my different chart right here, and I still know that the initial velocity of x is 41.45, and the initial velocity of y is 27.96 from doing the Pythagorean theorem over here and finding out the sines and cosine values. So what I did here was I knew that the final velocity of x was 41.45 because in these equations VI and VF of the x values are the same, and it's always acceleration for x is 0 and for y it's negative 9.8. So what we're trying to find is the how far is delta d of x. So once again we're going to use the y values first to find the time, and we know that the final distance of y is 0 meters. So this I wrote in, but we didn't know that, so pretend like we didn't know that. So over here I did delta d equals vi times t plus half a t squared. So I plugged in 0 for delta d, then 27.96 for vi. We don't know t, so we leave that as a variable, plus half times negative 9.8 t squared, still don't know t. Then we get negative 27.96 t after doing it out and bringing it to the other side, which makes it negative. And then for this side, we get negative 4.9 t squared. So they're both negative, the negatives will cancel, and then we can cancel one of the t's and make it negative 27.96 equals negative 4.9 t. So we're going to divide by negative 4.9 on this side, and we're going to divide over here, and we're going to get the time to be 5.50 seconds. So over here we can write in 5.50 seconds, and because we have all four of the values, we can use the original equation that we used for the related rate problems, and we're going to do delta d of the x value, because we're finding the x, equals velocity times time. So we don't know the delta d, but we do know the velocity of x is 41.45, and then we're going to multiply that by 5.50, which is the time, and we get the final answer to be delta d of x equals 227.98 meters.